Welcome to a wonderful, hopefully headache-free Friday morning in Madrid, TechEd, last day. I hope you've had a good week so far, and I'm trying to keep that up. I'm going to talk about messaging in Windows Azure Service Bus. My name is Clemens. I work on the Service Bus team in Redmond. However, I'm based in Germany for the last about half year because we have a lot of customers in Europe, and I moved back also for family reasons. So I have a job where I'm going back and forth between Redmond and Germany, but with that, I'm closer to you, and so you also see me at the occasional event throughout Europe now. That's something that I couldn't do before. So I'm glad to be here at TechEd, kind of as I'm back home kind of thing, and so that's great for me. I have with me Afan. Afan is going to help me with a demo later around AMQP, and I'll be talking about messaging. I'm going to give you, for everybody who isn't familiar yet with Service Bus, a bit of an intro alongside of the scenario. But then I'm actually going to go mostly into things that are new in Service Bus around messaging and what we've worked on so far. So I'm not going to go and do the basic introduction into Service Bus because we have plenty of material. Around the part of the plenty of material that we have, you find at Channel 9 at msdn.com. There's the subscribe blog. I maintain that subscribe blog, and there are in the order of 40 clips that you can go and watch. It's sessions. Sometimes it's walkthroughs of like 20 minutes, and some of them are talks, sometimes on the whiteboard, of about an hour time, or sometimes even 1.5 hours time, where I go into details. There's a messaging features walkthrough there, where I go really through all the depths and details of all the messaging features that we have, except the ones that I'm going to talk about here, because these are net new, and so I didn't have them in that walkthrough yet. So the subscribe blog on Channel 9 is something you may want to go to get really in-depth material, and also follow-on material, because that's something I update. And then we also have interviews with people from the team about how things were built, and actually have some insights into the back of it, like how do you actually run a scaled-out 16 data center service, and how do you do the testing around those things. We have a bunch of stories around that there as well. And if you want to follow me on Twitter, you can do that on at ClemensV. And also, if you want to tweet about this session, go ahead. But I will get you. So, agenda: introduction to Service Bus brokered messaging alongside the scenarios, and then I'm going to talk about mostly new things. And I'm also going to show you version 1.1 of Service Bus for Windows Server, and there I'm going to go and focus mostly on the new experience that we have in conjunction with the new Windows Azure Pack, and how that's integrated. And that's actually a very, very fine story for symmetric development. So I'm going to get to that there as well. I'm going to start with a scenario that's a real scenario. However, it's not the real scenario is not amir.lib. We just made that name up. And it's not strictly about a library, but this is a scenario that is actually real. So the story here is that a library has introduced a rich and cloud-hosted website. So they have, instead of hosting the website themselves in their own facility, they have now opted to build an application that runs inside of Windows Azure. Of course, they now still have systems on premises that they need, because they're still giving out books at their local system, and they don't want to make that cloud dependent. So if the internet connection is down, they wouldn't be able to go and hand out books, so they don't want to do that. So they want to retain some of their systems on premises, and they also have an Active Directory set up, or they have Active Directory on site. They have a billing system or a checkout system that sits on the back end, and those things remain on premises along with all the books, with all the physical things. But they have a website where you can go and check out books, you can browse the catalog, you can go and interact with. And that's something that they want to have, because they're serving a broad area. That's something that they want to have in the cloud, because it's just cheaper and more reliable to run there. So what they do is they're building a hybrid application in the sense of hybrid is one of those overused words. It's like service and cloud, and now it's hybrid. Hybrid means 1,000 things now. So what we mean when we say hybrid is you have an application which runs partially against IaaS or PaaS and partially on traditional means on your own hardware. That's what hybrid means for us in that context. And so they want to go and connect those things up. The first is, and this is a core messaging scenario, that's where we use queues and topic and subscriptions, is that you go and want to reserve something from the website. So you have a reservation that you make on the website for a book, and you want to get that back to the on-premises system. The way you do this is you create a message, and you put that message into a queue, and then the backend system that sits here on premises pulls that message off that queue. You can do that in a one-way fashion. You can make one queue, like I have that up here, and then you have the backends kind of pull that off that queue. Or if you wanted to take a reservation and forward that out to multiple places, let's say you want to do a model where you do an inquiry about how many books are available. I want to go and go into the libraries, into various libraries that you have across the region. Send one message in where you ask for a reservation. You say, if you have one, please send a message back, called correlation, back into this reply queue. So you fan a message out to all the libraries that you have. The system's there, check whether the book is there. And then the one of them which has or doesn't have the book, so whenever they have a message, then they're going to give you messages back into a queue that you maintain. So you can have a fan out and then fan back in pattern there as well. Those artifacts, queues, and topics. So topics are to distribute data. These subscriptions can have filters. So these are for one message in, potentially many messages out. And a queue is one message in, and then one message out with one receiver. But you can also have concurrent receivers on this. So you can have multiple readers, and they are serviced in the order of how they queue up their requests, and that's how you get queuing. If you're not familiar with Service Bus yet, but if you have used MSMQ, that's the next generation technology that follows up MSMQ, and our team also we maintain MSMQ, so we're making some fixes for MSMQ, also for the new version of Windows Server 2012 R2. But Service Bus is the next generation message broker, and the topics are a brand new thing as far as core messaging is concerned in that system. So that's one of the scenarios that you can use those for. You can create those queues. I'm going to show you in the portal. We're going to see that kind of on the way, how you go and create them in the portal. Then there are hybrid services, where you have a service that you expose from on-premises that you want to be able to use from the client. And these are typically synchronous scenarios. What we offer for that is the relay. The relay allows you to expose a service that you've written today in the Windows Communication Foundation in some future. And when we talk about futures, we are very short-sighted. So for us, futures is not 5 years, that's science fiction. But for us, futures is like a year. So as far as I can see, we're also likely going to support Web API for that directly, but right now it's a WCF service. You expose a WCF service here by way of changing the binding on that service. With that, the service edge gets projected out into Service Bus into the cloud. And that can be happening from behind NATs, from behind firewalls. We go across all the NATs and firewalls that there are. We create tunnels for either TCP or plain HTTP or HTTPS. And so then that service that is sitting kind of on premises somewhere in your system can go and listen now for messages on the public internet. We go and put a special security boundary on top of that, so the service doesn't get exposed unprotected. And that allows now this application which runs in Windows Azure to do just a standard web service call against that edge that sits in Service Bus. And then we actually forward that. And so if you have a service that's fronting Active Directory, you can now go and effectively make a call to say, is that librarian here actually legit? You go over here past the data, or possibly past the credentials, or you have a credential set here, and basically just check the identity. Check the identity against Active Directory, and then come back. So that's something that we also see happening. And any kind of web service that you might have that's implemented in .cf can expose that way. A scenario where I can name the customer, for instance, EasyJet, the airline. They're exposing backend services to handheld devices like this, backend services like check-in or seat ordering and all those things that they run in their own facilities, and they pull them up kind of to the edge, and they let us be, in Service Bus, be the external demilitarized zone for their services. And then we have the queuing up the requests for the billing system. So the billing system, if we go and build them, this is a commercial library, not the municipal library, then you can go and queue up the billing events or some other events that you might have, also diagnostics events, whatever you have, and you can go and put them into a queue and put them into the billing system. If you had bursts, so let's say if you were a bookstore, not a library, but a bookstore, and you were selling books or CDs, DVDs, and something terrible happens, right? My example with my apologies to Sir Paul is always, if Paul McCartney gets hit by a car, then the sales of Beatles albums is going to rise up very rapidly. We've seen that with Michael Jackson, right? All of a sudden, the guy hits #1 again. Unfortunately, he's dead. So when that happens, when you have these unexpected rushes of data, you get all these records in, and the queue will go and effectively level this out. The billing system will never get overstressed because it sits behind the queue. So these are the core scenarios that we have for messaging. So there's a good reason to have these queues, these topics, and these relays kind of in your applications, specifically if you have applications that are running across cloud and on premises, but also if you have applications that are running just in the cloud where you have a backend role, forward role, and you want to go and make those things scale. That's what Service Bus is. If you want to know more about the basics, like how you create a queue, how you send a message, how you receive a message, all those things are well explained in the large number of videos, 20 hours of content probably, that are in the subscribe blog. So from here on, I will talk mostly about the things that are new from where we left off in probably half a year ago. So we have been very, very busy adding new stuff. In the SDK 1.8, and this kind of shows you what the release cadence is that we have as a team. This is not as things were just a few years ago, where we would come up with a new release every 3 years. We're actually releasing stuff on a very, very frequent basis. So in October, we shipped SDK 1.8, where we allowed you to renew message locks. A lock is a thing you set on the message as you peek it out. So you can peek a message, you can look at it, you put a lock on it, and only when you complete the work, then you're actually deleting the message from the queue. What that gives you is reliability. If you crash, that message is going to show up again and will be processed by someone else. We actually keep count. So for a poison message detection, the message lock renewal allows you to extend the lock of the message while you have it in hands. It was previously fixed, now it's renewable, which means you can keep a message and you can actually, if you need to process something for an hour, you can keep renewing the lock on that message. Entity query, with that you can go and do queries across the entities, the queues, the topics, the relays that you have, and you can kind of find them by certain criteria. You can find whether something is running hot or a queue is very long. So you can do queries across the system. You can now forward messages between entities. You can go and make a queue, and you can put another queue at the end of it. So auto forward into something else. That doesn't seem interesting at first, but it's actually very interesting from a composition perspective, because you can now assign an application a queue that it queues into, and then you can hang another queue on the bottom of it. And if you want to redirect that traffic to a different queue, you now can go and do this by just changing the property on that queue, but you don't have to tell the other application to change the address that you're sending it to. So you have a fixed ingress point. That's one way to do this. The next thing you can do is you can do fan-in trees. If you have extreme bursts of traffic where you need to take 50,000 messages a second, you just make a bunch of queues, and then you kind of create a fan-in tree where you have those then groups of queues forward into another queue, forward into another queue, where you can effectively just create a funnel. So if you had devices, or if you had applications that are reporting at large scale, something exactly on the hour. If you have to deal with something like this, you can do a fan-in tree. Fan-out tree you can build from a topic. Build a number of subscriptions. Each subscription auto-forwards into another topic, create more subscriptions. So if you want to go and send a message to an audience of 50,000 different subscribers, we have a limit of 2,000 subscriptions per topic. You can create these trees through auto-forward, and that then allows you to kind of create this fan-out tree in basically arbitrary dimensions. We allow batching. We have browsing of sessions, so you can figure out what sessions there are, if sessions are a particular special feature. And then you can also update entities that we couldn't do that before, and you can also enable and disable. Then you can actually shut down a queue for traffic without deleting it, so that the queue no longer takes traffic. Then we added the notification hub previews. Todd talked about this, so you can review that session on the TechEd site. Todd talked about this, and we actually showed a demo of that yesterday. Then with the SDK 2.0 that came out in April, we have SAS. I'm going to show that. Auto-delete idle entities. I'm not going to show that one. What that does is, as you create a queue or a topic or a subscription, you can now set an idle timeout that's optional. So if you just want to have a subscription for something that may go away, a web session, or a mobile device which is connecting to your entity, you can set a timeout, and if we don't see activity, received or sends, on that entity for that defined time, the entity just goes away. So it auto-deletes itself if it becomes inactive. And the event-driven model, task-based async APIs, you're going to see those. Browsing messages you're going to see as well, and the other things you're going to see today as well. So I just want to give you kind of an update on SDK 1.8 here. We're going to keep that cadence up, so we have a lot of things in the pipeline that we're doing. You're going to see a lot of activity, also a lot of guidance from us over the course of the next year. Specifically also, since I talked about that fan-out tree, around machine-to-machine Internet of Things applications, because we believe that messaging is actually core for those scenarios. And so you're going to hear a lot of guidance from us. And there's already some guidance that we have. And so you're going to hear more about this from us, but also kind of we're going to go and add these features. And most of these features, pretty much all of them, are just based on feedback that we got from customers. And you see that release cadence allows us to actually be reactive. So it's an interactive thing that we do with the community. And I hope we're approachable enough to actually make that happen with you. So let's go and talk about some of the features. So one of the things that I need to do is first probably apologize to existing Service Bus customers for some rough days that we've had. There has been some bad weather in the data center occasionally due to things that happened at the back end of the storage system that we were using. But that is our problem. Right? The availability of our system is our problem, no matter what the problems are that we have in our dependencies. So we have been addressing some of those things. Right? Some customers have seen a large number of exceptions when they were trying to send messages, and we're also doing significant work around increasing the resiliency against any of those issues in our API. Oh. So the first one is the retry policy. So you can create on a messaging factory, you can now set a retry policy, and we have an exponential retry policy. You can actually go and set one, you can go and configure that one, but you have the default is here, or you have the retry, no retry policy. What the retry policy will do is if you send a message and we see an exception coming back in the bowels of the API which says this is retryable, we're going to do the retry automatically for you. So within a given time span, we will actually go and retry for you so you don't have to do that anymore. That's something that we had given out as guidance that you should always do a retry. Because even if the system is in perfect health, what always can happen because of upgrades, because of system maintenance, is that we need to go and take one of the machines or multiple of the machines offline. And if that happens and you just send a message as we're doing that, then you will get an exception who said we couldn't store that message. And now we're actually going taking that message and we're going to send that again automatically. So we haven't done that before. We're doing that now with the newest SDK. So the way that works is we're going to send the message in, and it's just going to work, and we're going to send that from the client multiple times. There's a feature that you can't see, which we also are adding, and that's the server-side send retry, where on the server side, if we see that one of our storage, your queue lives in a storage bucket, if that storage bucket has the flu, then we go and redirect to a different storage bucket. Automatically, we store the messages there, and we kind of then resync them on the back end. That's something that you can't see. That's some resiliency, reliability features that we add kind of on an ongoing basis into the system. The other feature that we're adding for that purpose is paired namespaces. So you can now go and pick, and this is something where you can basically create geo-redundancy more or less for yourself, or we can help you with that, is you can create two namespaces and pair them. And the pairing means that you can go and pick a namespace wherever that is. So you can go and put one into EU West, and you can put one into EU North. And what we do is we take the second one as a replica, pair your guidance. So you choose how you want to do this. The way that it works is we try to send a message into that first namespace, into any entity, and if that doesn't work for whatever reason, we go and send that into the paired namespace, into effectively a shadow copy of that entity. So it goes into the shadow copy of the queue, if you will. And then, if that answers again, if that's fine, we're going to send that into the regular namespace. And now this message is sitting here, and the paired namespace will go and take a look at the other namespace, at the primary namespace, and whether that's available again. So if that's out, if that has issues, right, the paired namespace will take a look at it, and will then go and route that message back into the main namespace from which it will then be received. So from a send-receive perspective, you're only dealing with the primary, and we're doing this magic on the back where we're sending into that paired namespace, we're holding the data there, and then we're replicating that up as soon as that's available again. So that gives you kind of built-in geo-availability. If the primary is down for whatever reason, where you can still send. You have a way to store the data, but to receive, you have to have the primary available again. And that is also for, if you can't get to it for whatever reason, routing issues on the internet and whatever, you have the secondary. To create this, you create a namespace, and then you have a pair namespace option that's also available async, where you can effectively say what your options are. You set the namespace, the messaging factory, the namespace manager for it. That's how you also specify the credentials for this, and how many transfers queues you want, etc. So you're going to configure that. More details about that in the documentation. Sessions and scheduled messages do work. Ordering is lost. So if the namespace, if the backend is kind of spotty, right? We send one message here, we send one message there, one message here, one message there. As they get reconciled, then the absolute order is lost. If you maintain sessions, right, then that may recover for some of that. The end-to-end latency obviously will vary. You have a fixed set of transfer queues, which limits the capacity of that. And do you own this? And of course, there's a billing implication because all these transfers, all those things, cost message transactions. Because if we give you higher resiliency, something you can control as a feature, obviously, we need to go and get some money for that because we do more features, more money. The next thing that's new is shared access security or shared access secret authentication. We shipped Service Bus in 2010, in January, after coming out of incubation for a long time. We started this in 2007 with 3 people. And that effort that we started was actually ACS, the Access Control Service, plus Service Bus, and that's how we started. And we started kind of going through the incubation phases and pains as a little startup within Microsoft, we're always one manager away from getting killed. We built these two services together, access control and service bus. So service bus has long had this dependency on access control because of history. And access control is great because it gives you, an external way to go and manage federations with other services and also manage identities that you can use against service bus. However, if you depend on two services, you also depend on the combination of availability of those two services. So occasionally, it has happened that service bus was rock solid and up, and access control was a little flaky, and so customers couldn't get to service bus. Also, there is a two-step thing you need to do. You need to first get a token from access control, and then you need to go into us. So that's something that's kind of adds a little bit to the complications. So what we did is we now have an intrinsic model in service bus that's looking a bit like the storage model, the Windows Azure storage model, but we've actually extended that a bit, and we're using the basics algorithm notion that also storage uses for shared access secret. So you can authenticate using an access key. That access key is embedded in the system, and effectively you can, if you're in possession of that key, you can give out tokens. Because that might be a little strange, without getting any guidance, I'm going to show you how that looks if I figure out how to do this. So this is my namespace, my service bus namespace. What I'm going to do here is I will go into my queues, and I have whatever. I'm going to pick this one. So you can now on the portal very easily add another authentication mechanism, and that is the shared access key. So here's in the configuration tab on a queue that also works on subscriptions and on topics. You can go here at the bottom, and you can go and edit the shared access policies. And the shared access policies, there we go. So you can go and give them a name, and then you can assign some permissions. So I'm going to give that a name. I'm simply going to call this read-write, and then go and edit the permissions. Let's go and do that here. There's a bit of a pop-up. And now I can assign, with that key that I'm going to assign, I can confer rights. So it's not like storage where having the key, there's two keys in storage, right? It's the primary and secondary. And once you have that key, you are God. That's not the same model here. You can actually give out these keys that already carry rights. So you can make a read-only key, you can make a write-only key, you can make a management key that you can go and manage things with, you can delete entity parts, and you can go and set combinations, and there are 12 slots. Because there are 6 combinations that you can conceivably make, and then there's a set of secondary keys if you want to do key rolling. So I can go and now I'm going to make a send and a listen key, so this is now good for send and listen, and now I have a policy. As I go and save this, and go back to the dashboard, here's my connection information. I now get a connection string just for that entity. So I have now a connection string that's only good to talk to that particular queue, and it includes the key information that only gives you read-write rights. So with that key, I cannot delete the queue. If I had managed rights, I could actually go and delete the queue. Here, that confers read-write rights. I could also give out a key that just gives you read, so I can only get data from the queue, or only write, so I can only send to the queue. That I can now give out to a client. The way that works, and the way you can construct that is we have, obviously, in Service Bus, a way to just very easily go and use those things. Let me go and find the right place here. I'll actually show you the REST part of this. So in REST, in HTTP, the way you go about this is you go and create one of these SAS tokens. And the SAS token, that's the mechanics of it, so this is how simple it is. You go and create this the signature over it. you compute the hash over the signature, and then you spit out this token. That token here that we're spitting out is one of those simple web tokens, SWAT, which is perfectly fine to go and include into a HTTP header. So these are the headers that Service Bus understands. So, and this HMAC SHA-256 is very easy to compute effectively on every platform. So you can go and do this from an embedded device, or you can go and do this on a phone, or you can do this from anywhere. And also, of course, in the mainline Service Bus SDK, we have token providers that we provide. So let me go and see whether that's actually token provider. So you can create a shared secret token provider here. That's how you create that token provider that you need for the mainline Service Bus SDK. And so that's using that. But here, that's kind of the raw form of how that's all computed. And so once you get that SAS token, you can now do two things. In fact, there's two submodels here. One is you do what this shows, and you effectively call receive. You make a token out of having the key name and having the key in your hands immediately. So that's the standard model that we give you. If we give you the connection string, if we go and review the connection string, what's actually in there, it contains, let's go and put that onto the clipboard, and then let's look at it in Notepad++ is always dangerous because it remembers the last things. Let's go and make this a little more visible. So this actually contains, as you can tell, the shared access key, the key name, and then the shared access key per se. So this, now you have the key in hands directly. So if I give you that connection string, you can now go and mint your own tokens as you like. So you basically come to us, but all you can do is read and write, but you can make your own tokens. That's one way to access those things. That's the standard way. So that's a connection string. We understand that connection string. You can use that connection string, but only against that one entity. You can't talk to anything else with that entity. That's number one. So you can be in possession of that key. Model number two is you can make these tokens, and you can assign those tokens a lifetime, and then you can hand them out to other people. So you can create tokens as you could create tokens with ACS. You can sign those tokens and give them out, so you can build your own little STS, and that STS gives out token to others. So you can theoretically, and those tokens are not bounded. We don't have any rules around them because we give you the key, and then you could make your own tokens, which means you could make a token theoretically that works for 2 years, and put that into an embedded device or put that into a phone app. And that phone app will never be in possession of that actual key. It will simply be in possession of a token. The way you can revoke access to all those tokens is to basically just go and change that key, roll that key, and then they're all going to be immediately invalid. So the only way you can kind of maintain access control on that individual level is to make the token lifetime relatively short so that they will go and expire and they have to go and get new ones. But with that, you have now two options. You can either go and sign your own, you can either have the client be in control, and if you do this kind of on a per queue basis, right, you kind of narrow the problem down to whoever has access to that queue, and you can make it a write-only thing. And furthermore, as an additional level, you can go and sign those tokens. We have a sample that the guys in Redmond actually coded up yesterday night because it was fun and I asked for it. Which we're going to put up somewhere. I'll probably go and do a subscribe session on that, simply explaining it. And so you're going to get this from my blog. That's probably the simple way. Which here the static simple web token provider. What that is you can get the token. So with this model, you can get the token, and then you stick that in here, and the token provider will return it. And then you will be able to use that with the normal Service Bus API very easily. So that allows you to kind of dish out tokens which only are valid for a particular client. The client doesn't get the signing key. And with that, you can make expiring access to a Service Bus entity with that simple web token provider. It's actually not that hard because the token provider class is public. So if you know how to make this token, And you can, for that, you can actually use our shared access token provider. So you don't actually need to have that code for that. Then you can go and derive that and basically just return that token that you get out of this. So much for SaaS. I'm actually presenting from here. And for the new things that we can do here. So that gives you a very interesting new model. What we don't have in that model is accounts. So as I just said, we have 12 slots per entity. We also have the same kind of slots at the namespace level. So you can create a policy at the namespace level. That's something you can go and configure also in the portal, where you can give a global read-write to everything that sits in the namespace, or a global write-write, or a global manage-write. So you can make a master token, if you will. A master key, if you will, and then also do that at the individual entity level. But there's only 12 of those. It is not a goal to have a identity provider in there. So it's not meant to be accounts. It's meant to be signing keys. And so that's why we put a cap of exactly 12 on this, which is, of course, totally arbitrary. But blame me, because I don't want to get into the business of being an identity provider. We want to have a model where you can be the identity provider if you want to be by using those derivative tokens. So next thing is the event-driven message programming model. That is sitting kind of here. Too bad I couldn't make this bigger. So client. So that's your whatever client you have, your queue client or your subscription client. And now we have a function that's called onMessage. And what onMessage will do, onMessage will, once you call onMessage and pass in a callback, in this case a lambda, we're going to start a receive loop for you. And we're going to start a receive loop, and that receive loop is built on all the best practices that we can ever imagine. It has exponential backoff. It is async. We have an async version of this. This is the synchronous one, so there's onMessage async. It's as optimal as we can make it. It is our best attempt by the best people that we have in our team to make a receive loop. Because so far, everybody had to write their own receive loop. So now we have a standardized, this is it, receive loop. You will still have your own receive loop if you need to do something special, but this is going to work for 90% of all cases. So we call this callback whenever we have received a message, and then there's also an option that you can tell us to, and that's not in here. There's the options down here. So where you can set the max concurrent calls. So we call you once, which only means we have one thread. Whether we're going to go autocomplete or whether you want to be in charge of complete. If you throw it out of the message, we're going to abort the message. We're going to abandon the message, obviously. And then you can also, if we get an exception, then we're going to go and call the event handler there. So that gives you kind of the receive loop that you always waited for. Go and use that one instead of writing your own, unless you have reason to go and write your own. But this will do it for most of it. And the max concurrent calls really allows you to kind of tune how many receiving threads and processing threads you want to have on your system. Next thing, the entity queries. We now allow you to go and query across the metadata that we have about this. So you can go and, for instance, get all the topics that start with foo and that were last accessed at a particular time. Or we can give you the subscriptions where the message count is greater than 0 and that were accessed before a particular time. So you can now, all the metadata we have in the system, you can do these OData style queries again, so you can get a kind of fairly rich information about your system, specifically if you have a lot of entities to manage, which is the case if you're building complex systems, for instance, M2M scenarios, or where you need to have a lot of topics, a lot of subscriptions, where we're talking about dimensions of thousands of entities. Then it's always useful to kind of get some insight into what's going on, so you can go and run these queries, and that's also very useful, obviously, if you want to go and build some tooling that's similar to what we give you in the portal. Then there's now Message Browse. It's a feature that MSMQ had for the longest time, and we've always longed to have, and we finally got around to doing it. That allows you to kind of peek messages out of the queue without locking them. So you can effectively, with that, now go and read the messages forward. And if you want to go and just make a list of all the messages that are currently in the queue, you want to take a look at them, you can do that. So peek gets the message at the top. You can go also peek from a particular sequence number, so you can go and take the message out. You can take a look at it. The sequence numbers are monotonic sequence numbers. However, you can get things out of order if you do peek lock, because we're putting message back in that maybe so. And then you can also go and do a batch peek and say, okay, so I know that there's 100 messages in there. Let me get the 100 messages so I can display them in the list. And you can also do paging with the from sequence number. So that allows you to go and browse that. Then, of course, we have task-based APIs. Everything that we have is now async supported. Before, we had always the begin and end. There's actually still good reasons for do begin and end, because there's some scenarios that you can't do with the async style. But generally, async and await in .NET 4.5, best idea in the world. Code is super clean. People are deleting tons and tons and tons of code. Great idea. Use that. Our general guidance, specifically also now that we have that support, is do everything async. Everything on the server side, always async at all times. Just a quick story around that. When we went live, as I said, January 2010, we were deploying into our Scalians front end, 96 front ends to carry the expected load. And then we did 2 milestones, nothing but cleaning up the system, because it was a mad rush to get to shipping. And what we did primarily was to eliminate all the remaining synchronous code paths. Without having any change in capacity, without having any changes around the system, we went from 96 nodes to 32 nodes. Just because we were async. That's the change. So on the server side, you should do nothing synchronous. Don't use wait, don't use sleeps, everything asynchronous, everything's based on callbacks, everything. And what async await does is it actually takes your code and shreds it apart so that it's actually callback driven. Because the way Windows does I/O is I/O completion ports. So it does it on a callback basis. So whatever the node guys are happy about and I'm doing everything async and it's all callback based. Windows has been doing that since '92, but we've kind of always under this wrap of an abstraction of synchronicity on top of the asynchronicity, and it's time to get out of that. So if you can, do everything async. So, close to getting to a fun time. Service Bus is supporting AMQP 1.0. AMQP 1.0 is a brand new, relatively new protocol that has been driven out of an effort mostly from Wall Street. The issue that the Wall Street firms had that were starting this, JP Morgan Chase, as a driver in Bank of America too, is that all of their business is driven through messaging applications. And that the incumbents on Wall Street who provide messaging technology have proprietary messaging protocols and have shown no willingness to go and open those protocols up. And so they said, well, we got to change that, and apparently we can't change that by talking to them. So we'll start our own effort and try to liberate ourselves from that, and so we have to go and build a new protocol. So they started this, and they got a bunch of companies to join them, infrastructure companies to join them, who are building software, and then eventually we also joined that effort. And David Ingham, my peer in the Service Bus PM team, he is one of the co-editors for the specification. And so we've been driving that, and that has become an OASIS standard in December last year, and we're now driving it towards ISO IEC standardization to become an ISO standard as a binary, bidirectional, multiplexed transfer protocol between messaging systems. So it previously was difficult to port apps, difficult to integrate, restricted platform support, all things that are helping, the two big companies which are selling those messaging systems not to integrate well with other messaging systems. And that's what they wanted to get out of. So AMQP, open standard messaging protocol, enables cross-platform apps to be working. You'll also see that we're actually taking that very seriously. There are a number of platforms that we will not develop clients for because we rather go and help, hold on to your seats, the Apache Foundation to do their work right, to go and make kick-ass clients for C, C++, and PHP and Python and all those things to make something that speaks AMQP right and that works really well against Service Bus. So we rather put our energy there to make sure that the open source infrastructure there is good and then have a way for us to go and support enterprise customers who are using that rather than having to roll everything ourselves because we really, really believe that open standards in that world are really important. It's a binary connection-oriented protocol. So it's not carrying JSON or XML. It has its own encoding. You can run, if you wanted to, you can run JSON and XML over it. But it's binary, super efficient on the wire. It's aimed towards minimizing byte count. It's very reliable. Cross-platform data representation. It's very flexible because it doesn't assume that there's a certain style of broker. So it's just a message. It's a transfer protocol, and the transfer protocol can be overlaid with broker semantics, but it's very easy to kind of overlay this broker semantics on top of that. So all these vendors, many small ones, some big ones, Red Hat we've been working with very intensely, VMware we've been working with, WSO2, Software AG, and then of course the user firms, you see that's all Wall Street, which are pushing this very hard. Also the Department of Homeland Security in the US, who are doing some messaging. They have also said they are one of the biggest users of IBM MQ series in the world. And they have said within 2 years, every message broker technology they adopt must support AMQP 1.0. IBM is one of the firms that I talked about earlier, so we'll see what happens in that space. It's going to be very interesting to watch. So AMQP has been supported in Service Bus in preview form for a while, and now we have support for that in SDK 2.1 and also in Service Bus 1.1 for server. So that's now all coming in. So we have AMQP is now officially supported on Service Bus, and what we're going to do is we have a proprietary protocol as well, because we had to start with something. And we're going to go and migrate off that proprietary protocol as fast as we can and move all the features that we have on top of AMQP. They're not all there yet because we kind of need to layer some things on top of it. But we're going to do that very soon and then have parity on AMQP and then kind of march on AMQP. So you can send data from Windows. You can receive on Java. You can receive on Python, PHP. You can send from Linux. And we have one infrastructure that's there. So Service Bus is kind of this multi-protocol, multi-platform rendezvous service for core messaging. What we still maintain as a principle in the system is that we don't futz around with your messages in the middle. So we're a routing infrastructure, we're a messaging infrastructure, right? I talked about the auto-forwarding features that we have, so we can go and route and auto-forward all those messages. Well, we don't have a transform thing in the middle. So we're not a heavyweight, heavy-duty ESB. If you want to have that, you can have that. We have BizTalk Services, and BizTalk Services kind of composes on top of this, sits on top of that technology. So if you want to have ESB-style things, you can go and compose BizTalk Services or BizTalk into the picture. So, Afan is going to come up and it's going to show you some magic with AMQP. Take.
So thank you, Clemens, and good morning, everyone. So I'm going to show a quick interop demo of that has become possible because of the recent announcement, the recent availability of AMQP 1.0 in Service Bus. So what I'm going to show is a single Service Bus queue that we will use to send messages between .NET client using our .NET standard library, and then messages to and from Java JMS application, and then we'll take it one step further and we will actually send messages from C application on a Linux OS. So let me start by creating a new queue, and I'm just going to call it interop queue because I'm very creative. And so the queue is there. There's nothing special I need to do with the queue. It is there. The queue can be used with any protocol that we have. You can use HTTP to send messages to this queue. You can use our native protocol that we have today in .NET Client to send messages to this queue. You can also use AMQP to send messages to this queue. So basically, there is no protocol. There's nothing you need to do special in terms of protocol with the queue. So I already had created a simple .NET receiver application. This is using our standard .NET client, and all this guy is doing it is creating a messaging factory, and on the factory it creates a queue client, and then it just till the end of time it will continue to receive messages and dump them to console. So I'm just going to configure this with the connection information for my namespace. And for that, I'll just copy paste it off of the portal directly. And I will also put in the name of my queue that I created. So at this point, this application, I'll just run this application. It is going to go into this while true loop and start listening for messages on the queue. And then the next thing I'm going to do is I'm going to open up Eclipse, and yes.
Look how Satan is loading.
So this is another application that I had already built. It is a simple JMS, a Java JMS-based sender. And then, the code is already there. I will configure that code. So servicebus.properties file, think of that as an app.config for this Java application.
Let me add that whatever you see here is all standard GMS code, which is to say we have nothing to do with that. The fact that this is slightly ugly is not our fault.
Yeah, so yes, we'll get into that. So the two things that I need to configure here is a connection string and then the name of the queue. So I'll just put in the name of the queue. It is interop queue. The connection string format is slightly different from what we have in the portal. So this is the JMS's AMQP format, and the three things I need to plug in here are the username, the password, and the namespace.
So for this, we're using the Proton Java client, right?
Yes.
So the Apache Foundation runs a project called Cupid, which is also a broker, and they have a client. A client is called Proton, and that comes in two versions with some subversions. And this is the Java JMS client for AMQP, and we're using that here in AMQP-S, which means the secure way to do AMQP.
Yes, that is correct. So for the username, I can simply use the default issuer, and I'll just plug that here. And the namespace is TechEd demo. The password needs to be URL encoded. So the password that we get from the portal here is not URL encoded. So I'll just copy it and I'll open up. And you can use your favorite URL encoder online. And just encode it and then copy paste it. So some manual steps here, but it works. We like it. So it is now configured, and what this code is going to do is, in about 100 lines of code, we will be able to send one message. So it will load the properties file. It will create a connection factory using the properties file. This is standard JMS. It will create a connection from the factory. It will create a session from the connection. It will create a producer from the session, and then it will send a message using that producer. Message being the thing that it gets from the console. So yes. I will run it, this guy, and let's see. Yes, so I will say hello from JMS, and it should appear here. Yes, so there we go. So we have at least JMS now talking to service bus, and then our .NET client picking from service bus. Now we're going to take it one step further, and I'm going to log into my Windows Azure Linux box, which is actually a CentOS 6.3 box, and I'm going to just run that. Azure. So here I'm going to use again the Proton C library, which I pulled in its raw form from the Cupid Apache Proton site. So I downloaded the tar file, unpacked the tar file and all that. And now it exists under Cupid Proton 0.4. So I'm just going to go, and I built that. So I'm going to go to the examples. So it already ships with an example of a sender that you can use to send messages to arbitrary AMQP compliant endpoints. So I'm going to take this. I'm going to take the messenger C sample. So it has send a sample that sends a message to an address. And actually the code for this guy is straightforward. So I'll just open the code real quick. It's a C command line application, and what this guy is doing is creating a Proton messenger object. It's starting the messenger, which is starting this messenger service, and then it is grabbing the message text from the command line. It is putting the message inside the in-memory buffer in the Proton messenger, and then it is calling messenger send, which kind of flushes that message out to the network.
Which is slightly easier than in Java.
Which is slightly easier than Java.
Only slightly.
Yeah, yes, that is true. The PHP version of this is even simpler, so you just send. That is nice. The sender actually expects an address, so I'm just going to copy paste this one. The address is basically the similar string to what we had in JMS with two differences. This one does not require us to URL encode the string, which is good. And then for this address, we have to add the queue name as a suffix to the URL.
So how much did we have to change on the sample app? Nothing.
0. So we just set the address, and we're just going to use it in its raw form. So I'm going to send top world, and hopefully, yes. So we have this guy. So basically, now I can send messages from this, and obviously it works the other way around as well. So I can send messages from .NET client, and they can be received from this. And the thing I would like to point out is that we have full type fidelity between these platforms. So I'm just demoing strings, passing along. But if I can, in JMS, I can pass a map or a dictionary or an array, and it will pop up as a .NET map or dictionary array. So that is something that you cannot do in HTTP. You have to jump some hoops. The second thing is it's obviously a connected protocol. So it is very efficient, compact, and all the nice things that you mentioned. So yeah, that's pretty much it.
Good.
Thanks.
Fantastic. So we're taking, as you can tell, we're taking all that interrupt stuff really, 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 really seriously. We have now, and I'm actually very glad that we now have stuff to show for it, because you can take those standard samples and run them against Service Bus. Now, that was not without work. I will allow one question. Yes. Yeah. I said that there's no full parity for AMQP yet. Yes. So there's two big features that we don't have support for yet. Service Bus, the .NET API supports transactions. So transactions in the sense of SQL transactions that you can actually go and group operations. So you can group a send. We can actually group a receive and a send. And there's also send via, which allows you to go and do in transactions. You can go and group a receive and a complete in transaction. That transaction support is not yet supported on AMQP. And then also sessions don't yet work on AMQP. But everything else, in terms of just regular messaging, all just works fine. So these are the two big groups of things that don't work yet on AMQP. We're working on fitting that, and then we'll have that working. It's not so much of a problem because all the other platform APIs that you might be using don't support those features either. So you're not really going to lose anything. So that's special features in Service Bus, and we're going to go and effectively build a way for you to leverage those features by setting properties, etc., on the protocol. So we're building a profile for that. Further questions I'll have to ask to be asked once I'm done. Service Bus for Windows Server is the on-premises version of the thing that we give you in the cloud, with some changes, with some things that are a bit different. The reason why we ship it is for several reasons. Here's 3. First of all, just a messaging middleware. Think of this as MSMQ vNext. MSMQ is a peer-to-peer queuing system, right? You can have a local queue, and that replicates off to another local queue. It is proven okay, it's reliable, but it's a peer-to-peer system, it's not a brokered system. So there's a bunch of things that MSMQ just per pattern can't do, and where it's constrained. So this is now a different thing. This is a message server. So you install a server, and you can go and scale this thing out. We support officially, like if you want to call support and you want to get some help, you can get 3 front-end nodes, and you can put this onto SQL Server 2012, also with the no-share replication option that is very close to SQL database in the cloud. So you can go make a very highly available cluster with that, which actually has a bunch of capacity. If you use the right hardware, so a 16-core machine with 32 gigs of RAM, and so plenty of capacity and headroom also on disk, then you can actually drive the system to support, in the order of 25,000 messages per second on a queue, and doing that on multiple queues in parallel. So we're actually I/O bound on that front. The faster the disks you put in, the faster Service Bus will go. We've so far pushed it so far to 25 K messages per second, but that's a limit mostly that's based on the hardware, or not necessarily of the software that's in there. So if you need to have a middleware system for messaging, you can use Service Bus for that, for your own scenarios, and it gives you effectively exactly the same capabilities that we have in the cloud for messaging. What's not there is the relay. That's not included, and also the notification hubs are not included. The relay, we might still bring in the server in one of the future versions. Notification hubs is unlikely, because notification hubs already take a dependency on cloud services, APNS, Google Cloud Messaging, and on Windows notification services. It makes very little sense for us to actually give that to you on premises, because we have a special relationship with all those vendors, and the notification hubs implementation is a bit of a nuclear weapon when deployed against those push notification systems without supervision. So that will likely stay in the cloud. So messaging middleware. Then you can go and develop against Service Bus offline with Service Bus for Windows Server. You can go and use it for that. And also you get the deployment flexibility. If you develop against Service Bus, you now have the choice whether you want to deploy on premises or whether you want to deploy in the cloud. So in the middle one, that's kind of the developer scenario, and then the deployment flexibility that you get out of that. What we now have is the Service Bus 1.1 preview, which is, from a feature perspective, nothing spectacular for people who have been following Service Bus. It is us catching up. So the way Service Bus for Windows Server works versus the cloud is that in the cloud we ship features every month, somewhat. We have releases, so it kind of is typically like every quarter or every half year where we have big releases. But we ship little things, little improvements kind of every month. A lot of them are on the server side, so you don't necessarily see them, but they make the system better. And so there are changes to the messaging engine. And as we now have moved to a release cadence for Windows and Windows Server of a year, and that's going to be like clockwork, you should even expect the release date of Windows, of the next version of Windows, to be pretty much aligned with the last year's release date. We're going to effectively catch up and then also release Service Bus for Windows Server kind of on the same cadence, and then catch up with the features that we have. So what that thing will have is AMQP support, and it's going to be consistent and supported with SDK 2.0. So what happens is the last release, the last supported version for that common SDK to have complete symmetry is 1.8. And now we're actually snapping to the new features, and now SDK 2.1 can again target both server and service. As we go on with SDK 2.2, 2.3, 2.4, it should be expected that like 2.2 2 or 2.3, likely 2.3, won't support the server again because the server then has fallen too far behind. So, but we always keep these SDKs available, so you can actually go and if you want to have symmetry, you can go and develop the thing, but the server will always fall a little bit behind because it is not feasible to actually ship on-premises software in that cadence that we do that in the cloud, because of the release mechanics for us and also of the deployment mechanics for you. What I'm going to show you, so we already showed you MQP support, so I'm not going to send you again sending a message. But I will show you the brand new integration that we got. And I'm on one. And that is on the portal. So this is now on my machine. This is Windows Azure Pack. Windows Azure Pack is an absolutely phenomenal thing that you can now download in preview. You can get the web platform installer, download it. What you can't do is install the portal and Windows Azure websites on one machine. If you do that, then I don't know whether they fixed the bug yet, but this will put your machine into a reboot cycle, as I found out. So Windows Azure websites is exactly the same infrastructure that defined in Windows Azure. What they will do is if a machine is suspicious, it will go and take that machine and shoot it out of the sky. So it will go and reboot it if it's bad. Those things are not compatible, and I didn't know that, so I installed them on the same machine. And the Windows Azure website was slightly wedged, and it looked at itself and said, "I can't live like that," and then go and committed suicide every 5 minutes. And then I asked, "Are you actually thinking of shipping it like that?" And they said, "Well, that's not supported." But the portal, so this is now not having websites, but this is now the portal, and Service Bus and the portal can exist on the same box. This is kind of the meta portal. What you can do in the meta portal is you can register services. So what you can go is you can add clouds here. So this is the management service with the portal on top of it. And so you can add a website cloud, and you can add a VM cloud, and you can add a Service Bus cloud. So that's what I did here. And so I can go and connect to another Service Bus instance, and that's the Service Bus instance. You can go and set this up. We have the setup wizard. I'm not going to show you how to do that piece. We actually have also some guidance on the subscribe blog. Ziv is showing how to do this, so you can find that on the blog. So you set this up, and then you now can go and connect an instance of Service Bus or Windows Server into that portal. This is the manager experience. So you can now go connect those clouds up, capacity effectively, into your portal. And then you can go and group those things into plans. So there are plans. And I have one plan, and this is now kind of the cloud I can go and book. So I have existing subscriptions. Here's a configuration that I can go. So I have invitation codes that I can configure. I can advertise it, blah, blah, blah. And so these... and I can add services, I can remove services. And as you create those plans, you can go and create a kind of self-provisioning plan for users who can then go and get a bit of Service Bus, and who can get a bit of VM, and who can get a bit of websites, and who can get all these things. You can group services together. And then if a user comes in and self-provisions a service, then, and the sign-up portal is here as well, they will get that plan. So I did that already. So let me go now go to the user side of this. That's also hosted in my app. So I'm going to log in here. So that login is local. And now I'm on the tenant portal on my machine. That it's all running on the notebook. Go. And in my package, in the package that I gave you, or that I used here, I have Service Bus, and I made a namespace, so that's exactly the same thing. I already have a queue in here. I can go into the queue. I can go into configuration. I have a shared access policy, exactly like the one that I had. I can go and roll the keys here, etc. So I get exactly the same experience. So specifically with SaaS, so the difference between Service Bus for Windows Server and Service Bus for the cloud is that the federated security model, one is, so for Windows, for Server, it's based on Active Directory. So you can actually use Windows accounts against Service Bus. In the cloud, it's based on ACS, so you can use ACS accounts and ACS federations against Service Bus. In the middle is shared access keys, and shared access keys are exactly symmetric across those two systems. So what you get with Service Bus for Windows Server, when you add that portal on top, you effectively get exactly the same experience, and you get all the metrics, right? You get all the funny graphs and all this. You get exactly the same stuff on premises as you get in the cloud, and then effectively it's your choice. When you do the math on pricing, 1 million message transactions, a message sent in is a message transaction, message pulled out is a message transaction, right? And then some other operations are also message transactions. You can go to the FAQ. If you do the math, you will have to send a ton of messages, very, 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 very many messages, to justify standing up your own infrastructure yourself and managing that own infrastructure with hardware and software and licenses and all those things. So it's great for environments. Service Bus for Windows Server is great for environments where you really have to have the traffic nearby, low latency, etc. But typically from a run it yourself, run versus build perspective, especially if you have things that are cloud connected or in the cloud, that Service Bus for in the cloud, Windows Azure Service Bus will always be cheaper, always more efficient from a cost perspective to run. And that's also a goal, certainly, that we have. So much just as a kind of to show you what Service Bus Windows Server is. You can get the Service Bus 1.1 preview today from WebPI along with all the portal, and of course you get the production version, Service Bus 1.0, which doesn't have the AMQP support, but otherwise it's also symmetric, also through WebPI or through a direct download. Oops, here we go. Where did we go? Here did we go. So it's running on Windows Server 2008 R2 SP1 or higher. That's the equivalent of Windows 7. It also runs on Windows 7 and Windows 8. In a developer scenario, it's not officially supported, so don't call us if you have issues running it on a client OS. But you can go and use it on a client OS. But the EULA it's included in the license for Windows Server. That's kind of how that works. So it's only supported officially, supported on Windows Server. Highly available, has a multi-node scale out, exactly the same thing we have in the cloud, just on a smaller scale from a support perspective. Again, their support perspective doesn't mean it doesn't run. It just, if you scale out across over 3 nodes, you're just not going to get any help. That's what that means. But that's something that can certainly, you might be able to get that if you are a very large customer, then that's a somewhat different story maybe. Windows authentication with AD. There's a System Center management pack to put this in. There's a PowerShell for administrator. And then there are the new portals. Cloud symmetry, as I said, it's the same connection string thing. And it goes from the developer choice one box, as you see, all running on one box, to a fairly large setup. You can run it against SQL Express. You don't need to have a full SKU of SQL. The more reliability you want to have for your storage, the more you can build out SQL Server. And we're actually adapting to that fairly well. So I already showed you that. So our release cadence 2.1 just came out, SB preview, consistent support with the SDK 2.1, which has also been released, and all those features that are in there. Related content, some things to look at. There are some sessions which you will also, like the Birds of a Feather, which you can also find at the Windows Azure North America site, because there's no sessions coming anymore. So there's some of the North America sessions are here as well, which you can go and review on Channel 9. And that's what I had for you today. If you have any questions out of the room? One question? Yeah, so what's the roadmap? So first of all, what we have as our roadmap is interesting because we have ideas what we're going to do, but we're highly reactive to what customers want. Now, you asked specifically whether we want to be a message broker or whether we want to be an enterprise service bus. There's a clear distinction between those two things. Enterprise service bus is an amalgamation of features around integration, adapters, transformations, etc. We have that service, and a server for that is called BizTalk Server. BizTalk Server is our infrastructure for this, and BizTalk Services is the set of capabilities that exist for that in the cloud. Enterprise Service Bus as a pattern, you can look at again, on subscribe on my blog. I have an hour-long rant about that. Enterprise Service Bus as a pattern means you have a central point through which you route all your traffic in your enterprise. That is, and that is my personal opinion, enormously stupid from an architectural perspective, because you're building yourself a bottleneck for availability, you're building yourself a bottleneck for everybody needs to agree on the same set of policies. It is not a very wise thing to do, especially as we're now entering an age where you have your customers have terminals in their hands, right? They have mobile devices, and the mobile devices speak to you. So you now have messages that are coming in from those mobile devices at rates of hundreds of thousands. Do you run those through your ESB? And if you don't, why do you have one? So what we have success with is federated services, where capabilities for integration sit at the edges towards the systems you want to go and integrate with, but there's no rendezvous thing in the sky. And that's what the ESB vendors try to sell you. You know what that doesn't scale? Because you buy the license for a core, right, for one core for $20,000. You know what happens? People build a cluster of 4. And then they try to run all that traffic through that. That doesn't scale. So I believe that the ESB pattern, as prescribed, is broken. The ESB capabilities that are making up that set, we have them at Microsoft. And we also have an ESB if you want one, right? So BizTalk is Microsoft's ESB product. And if you want to build an ESB, you can build an ESB, and it's a great platform for that. From a pattern perspective, we believe that in the Service Bus team, certainly, that the best thing is to build a scale-out platform and do integration at the edges, and that's what our customers have success with, and that's also why we have, the products that we have a message bus that allows the federation, the flow of messages, very broadly. Roadmap, you will see us investing very heavily in scale-out. You will see us investing very heavily in things like communication to devices. We're a software and devices company, and devices from a single chip, a $2 device that runs no operating system, to things that run on embedded Linux, that run on Windows CE, and allow to integrate them to do bidirectional connectivity to them. So that's, if you think roadmap, Service Bus is going for scale. BizTalk Services is going for depth. That's kind of where those two things effectively are headed. And with that, thank you very much for your attention. Thank you for coming. Have a good day.